Hello, everyone. I hope that you guys are doing great. So this is the practice final exam that I have prepared for all of you for Math 100. Remember that this is a partial practice final, therefore, this is only one item where you can study from. Of course, you have your homework assignments, your old exams that you guys can study from, and of course, your notes. You will be allowed to use this for your final exam. Alrighty, so this practice final exam that I have prepared is only 20 questions. Your final will have 28 questions. So please make sure that you are having your time very wisely and you're timing yourself when you're doing these type of questions. The first question that I have is a cross product question. Given that you have the cardinality of A cross B, given that A is equal to 2, 3, 5, and 7, and B is 1 and 2. Remember, the cross product is of N and B. You have 2, comma 1, 2, comma 2, your combination between these two. Then you also have, of course, the order does matter. You have 3, comma 1, 3, comma 2, 5, comma 1, 5, comma 2, 7, comma 1, 7, comma 2. So here's 1, 2, 3, 4, 5, 6, 7, 8 in total. So the cardinality of A cross B is equal to 8 because you have 8 missing in total. And I do want to see all of your work. So I do want to see you list them out. Okay, so this is what I'm looking for in your solutions. Okay, so if you just give me this, I will only give you partial credit. You should always show me the list. Okay? So based on that, we can answer the following question. Find A cross B given the cardinality is 6 and B is 2. So remember that B cross A is the same as N of B times N of A. With the multiplication, we know that it's an equation. N cross B is 6 is equal to N of B times N of A. Then the cardinality of B is 2, right? Because there's 2 items in there. So 2 times N of A is equal to 6. And then you just solve an equation. We have 6 is equal to 2N of A. You divide both sides by 2. You're isolating the cardinality of A. So then you have 3 is equal to the cardinality of A. So 3 is the cardinality of A, which is exactly what we're looking for. Alrighty, number 3. So this one you are asked to do a Venn diagram to answer the following questions. You have to do the Venn diagram. If you do not do the Venn diagram, you will not receive credit. All right, so the first thing you want to do is you have total of 50 students. We're pulled 25 like hip hop, 15 like rock, 20 like country. So we have 25 plus 15 plus 20. I think there should be here. Let me change this number to 70. Okay. So I made these questions up. Let's see. So you create a Venn diagram. So we have hip hop. I'm gonna let A be hip hop. So this is A. Let me let B be the rock. So here I'm gonna do another circle. And then I have a last circle, which I'm gonna call C, which is country. So there's 3 types of music. 25 like hip hop. 15 like rock, 20 like country, and then we have 13 like hip hop and like hip hop and country, 9 like rock and country, 12 like hip hop and rock, and 5 of them like F3. So this is where you start. You always start in your Venn diagram, all 3. So there's 5 of them. So the 5 will go right in between here. 5. Okay? Because all of them where they all match is here. This is the country. Now we go backwards. So we already know that 5 like both. 5 like all 3. Now 12 like hip hop and rock. Well, which one is hip hop and rock? Hip hop and rock is A and B. So hip hop and rock, A and B right here is 12, but you have 5 already. So 12 minus 5 is 7. So 7 goes here. How did I get 7 again? Well, 7 plus 5 makes 12. The 5 is already part of the all 3. Okay. Now go backwards. Now you have 9 like rock and country. Rock is B and C. 9 of them. So you have 5 already. 9 minus 5 is 4. So then here you have 4. Okay. So 5 plus 4 is 9. Rock and country. Now you have hip hop and country. Hip hop and country are how many? 13. So 13, we have hip hop and country, hip hop and country. Right here, the black and the pink. 13, we already have 5 of that, so you should have 8 here. 8 plus 5 is 13. So that's going backwards. Okay, now 20 like country. We have 8 plus 5 plus 4. That's what? That's 13 plus 4, that's 17. 17, we have 20 like countries, so then we have 3 over here. 3 plus 5 plus 4 plus 8 gives you 20, which is exactly the whole block length. Now 15 like a rock. Let's see. The rock is this color, so I should increase that number. Let me increase that number. Let me make this. Let me increase this to 30 and this to 25. Okay. So then 25 like rock. So if 25 like rock, you add 7 plus 5 plus 4. That's 9, that's 16. 16 plus 9 is 25. Because you have 9 and 9. That's 18 plus 7, that's 25. Now you go to the next one. Finally, the top 30 of them. You have 7 plus 5, that's 12, and 8, that's 20. Here you have 10. Okay? So this is your Venn diagram. This is the first thing you have to do. Create your Venn diagram. Okay, so let me go back again and start from scratch. You first create your 3 circles. A is hip hop, B is rock, and C is country. 5 like all 3. So you start with the 5. 5 like all 3. So you put that in the middle, then you go backwards. 12 like hip hop and rock. Hip hop and rock is the pink and the pink and the blue in the middle. 7 plus 5, that's 12. And then again, 9 like rock and country. So that means the blue and the black makes 9, and so on and so forth. Okay? Now that you have that, we can answer the questions. It says, how many of these students like exactly 2 of these music? So exactly 2 would be the pieces that are right up in the middle. So where they like exactly 2, would be exactly 2 would be 8 plus 4 plus 7. That's exactly 2. Not counting the would be this part, and this part. So exactly 2 would be 8 plus 4, that's 12 plus 7 is 19. 19 students. Like this genre. How many of these are exactly like 1? So if exactly 1, it could be either 10 plus 9 plus 3. The numbers on the outside. That's exactly one of them. Okay. So that would be 22. Okay. How many of these like none of them music? Well, you first count the total. We have 70 students that played minus, right? Well, you have 10 plus, you have 10 plus 7 plus 5 plus 8 plus 4 plus 9 plus 3. We have 70 minus, we have 12, 12, 12. That's 36, that's 46. So then we have 70 minus 46. If we choose a calculator, go ahead and do that. We get 24. So none of these students like any peppermint. 24. Okay. So then the next question is, how many of these students like rock, but neither hip hop nor country? So all you're looking at is a piece of the rock right here, but neither hip hop nor country. So that's only nine students. How many of these like rock? And exactly one of the other two. So then they like rock and exactly one of the other two. So either you can be 9 plus, because they're counting the people that like rock, plus one, exactly one of the other two. So exactly one of the other two would be either this um, plus 7 and then plus 2. You would count the 7, but you would count the 4. So 9 plus 7 plus 4, we have 11, and we would have 24. Okay? So here would be 20. So all you're doing once you have your Venn diagram is counting and adding. That's it. Okay? So please make sure that you're looking at the Venn diagram and then you're answering the question. All right. All right, next question is find the value of the intersection, the cardinality of the intersection given n of A or B. Well, first you use the formula n of A plus n of B minus the intersection. So what you know is, you know that this is 24. You know the cardinality of A is 12. You know the cardinality of B is 16. And you don't know this part. So first, you have to solve this equation. What you want to do is you have 24 is equal to, right here we get 30, sorry, 28 minus n of A union B. So here, 28 minus what gives you 24? Well, the only answer, what you would do is move it over, set the equation. You have n of A intersect B is equal to 28 minus 24. So the union that we're looking for is, and that is our solution. Okay, so you use the formula. That's my hint. You want to show all of these steps when you're doing the final. I do need to see all your worked out solutions. So all of what I have is must be shown. Okay, if you don't show your work, you will not receive credit. All right, number 5, decide whether the statement is true or false. So this one is, if the antecedent of a conditional statement is true, the conditional statement is true. So first, let's study what does it mean to be the antecedent. Remember, a conditional statement, let's digest this first. You have P implies Q. P is the antecedent. So, and Q is called the consequence. So if we do a table, we have P and Q, and then we have P implies Q. We have true, true, false, false, true, false, true, false. For an implication, true, true is a true, true, false, that's a false, and then all of them are true. So this is the only one where it's false. And they're saying that the antecedent is true, and the conditional statement is true. So you're looking at the results that give you. So then you would have to say the statement is true when the conditional statement is true. So let's look at the statement. We have the statement is false whenever the antecedent of a conditional statement is false. The conditional statement is false. No, that's not true, right? So let me my pencil is not working. Okay, now it is. So let's look at the possible choices. This one's saying the statement is false whenever the antecedent of a conditional statement is false. No, that can't be because we have that the antecedent of the conditional statement is true. The statement is false if the antecedent of a conditional statement is false and the consequence of the statement is false. No, that's not true either for us because remember when your antecedent is true, the consequence is true, then your statement is true. The only where is false is where you have the antecedent to be true, but the consequence is false. That's the only time. But we already know that the conditional statement is true, so we're only looking at this option. The statement is true whether this is good. The statement is true whether the antecedent of the conditional statement is true or false. No, because the antecedent, if the antecedent is true, but the consequence is false, then you would have a false statement. This statement is true whenever the antecedent of a conditional statement is false, the conditional statement is true. No. So the only option would be the statement is false whenever the antecedent, if the antecedent of a conditional statement is true and the consequence of the statement is false. That's the only time where you have a false statement on your antecedent. That's it. Decide whether the statement is true or false. Well, again, you have the same thing, P implies Q. But all this is Q implies Q. We know that Q is false. So this is false. And then we know P and false statement implies are. So if our consequence is false, we only have these two options, this one and this one. We have two options. We know that P and a false implication implies an R, implies an F. This part is either true or, so we're looking at this scenario and we're looking at this scenario. So if we have the true implies a false, this is be a false. If I have a false implies a false, then I will get a true. And the way that we look at it is if we have an implication of false, false implies true, this automatically is true. Because if we look at the antecedent being false, it won't be true. But what do we know about P? Okay, so P and the true statement, and if we have an and statement, P and a true statement implies a false statement, then we have that either P, so what you're doing in this problem is you're studying the different cases you can have. So P, if P is true, T and T implies a T. If P is false, you have false and true implies a false. So when you have false implies false, you get true. And if you have true implies false, you get a false. So your answer is exactly what I have highlighted. So you're studying the case of P and the implication. Okay? We already know that this F, this part, we know that P was false. But whenever we have a false implication, we will always have something true because false is an antecedent. Okay, so what happens prior to. Next step is construct a truth table for the following statements. So for a truth table, we have first identify the variables. Two variables. Which variables? Well, P and Q. So then you will know you have four rows. You have P and you have Q. You have not Q. You have not Q implies P. And then you have not Q implies P implies Q. So all of this has to be in there. Then you have true, true, false, false, true, false, true, false. This squiggly line means you're negating Q. So negating Q would be the opposite. So it'd be false, true, false, true. Now you're looking at this column. The not Q implies P. So you're going backwards. F, T, 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 F, F, T, F, T, false. Remember, now you're going this direction. Okay. Now your antecedent is your not Q. So F implies T, that's T. T implies T, that's T. F implies F is F, and then T implies F, that's F. Now you're looking at this column implies Q. So T2 is a T. TF, that's an F. TT, that's a T. FF, that's a T. So your solution is exactly this column. So please be very careful on noticing your antecedents. You have to be very careful with your truth tables. Now you create your other truth table. Again, you identify. You have P and Q. This is Q. So here, this is P and Q implies P or Q. We're trying to do the truth table of that. So I want to see all of your work. You have P, you have Q, you have P and Q, P or Q, and then you have P and Q implies P or Q. So again, true, true, false, false, true, false, true, false. Now, whenever you have an AND statement, P and Q, T and T, that's a T, T and F, that's an F, they're all Fs. And the other one, P or Q, they're all T's except the last one, F or F, well, that's an F. Now you're doing the implication. You should already know how the and the or looks like. Okay, I'm not going to go over that because you should know how to do that. 2 implies 2, that's a 2. F implies a 2, that's a 2. F implies a 2, that's a 2. F implies an F, that's a 2. Because we have an implication. So this is a tautology. Meaning that all are true. From your truth table. So 2 implies 2, F implies 2, F implies 2, F implies F, that's a 2. The only place we would get a false is if we have a T and then an F, okay? Yes. All right, next step. This one's a little bit different because you have now 3 variables. So for this truth table, you have 3 variables. That means you have 8 rows. So I'll show you. You have Q, you have Q, you have R, you have not P, not Q, you have not P or not Q, then you have not P or not Q, and R, and then the last piece is not P or not Q, and R implies P. Okay? All of this have to be shown step by step. So you're digesting the whole thing, you're filling them up. So then, whenever you have 3 of them, then I'm going to separate them like this. And you have 8 rows because I have 3 variables. So for this one, you have 4 of them, T, 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 T. And then here, there's false, 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 false. Okay? I'm doing them big so that you guys can see it. False, 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 false. Here would be T, T, F, F, T, T, F, F. The last one would be T, F, T, F, T, F, T, F. Now you're negating the P. Negating P would be T, T, sorry. Oops. Would be F, 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 because you're negating. And then now T, 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 T. You're negating Q. Would be F, F, T, T, F, F, T, T. You're negating Q. Now you're looking at an or statement. You're looking at P. Sorry, you're looking at not P or not Q. So you're looking at or F, that's an F, that's an F, that's a T, 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 that's a T. The only time whenever you have a false, whenever you have an or, is when both of them are F. F, 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 T, F, T. Now you're looking at not P or Q and R. So you're looking at this column and this column, and you're looking at an and statement. F and T, that's an F, this is an F, this is a T, this is an F, this is a T, this is an F, this is a T, this is an F. You only have a true whenever then both of them are true. Okay? The rest will be false because you have an and statement. Now the last piece is to look at this column and P. Because, so you're doing F implies T, now you're doing an implication. F implies T, that's a T. F implies a T, that's a T. T implies a T, that's a T. F implies a T, that's a T. Now be careful, T implies an F, that's an F. F implies an F, that's a T. T implies an F, that's an F. F implies an F, that's a T. And finally, that would be our solution. So you need to be very careful. There's a lot of margin of error here. Okay, so be careful. Don't mix and match your T's and your F's. Okay, this is a long one. So be very, very careful with your T tests. Okay. Now, number 8, determine the number of rows that the truth table will have. Do not construct a truth table. So what you're looking at, the number of rows are in terms of variables. How many variables do you see? I see P, I see Q, and I see R. That's 3 variables. So how many rows? Well, that's 2 to the third, which is 8 rows. So it's always 2 to the variable power. So we have 3 variables, 2 per 3. We have 4 variables, 5 variables, 6 variables. All I want you to do is tell me the number. You don't have to, do not construct a truth table. So this is 8 rows. All right, use truth tables to decide whether the pair of the statement is equivalent. So you want to create 2 truth tables, this truth table and this truth table, 2 of them. Well, you should already know how to do P implies Q because we've done that a zillion times right now. True, true, false, false, true, false, true, false. But we already know that only in this case, this is false. The rest of them are true. Now, if you look at the upper one, not Q and P, we have P, we have Q, we have not Q, and we have not Q and P. So here we have true, true, false, false, true, false, true, false. Now we're negating Q. This would be false, true, false, true. So we're going to look at this and I'm looking for an and statement. F and T, that's false. T and T, that's a T. F and F, that's an F. F, T and F, that's an F. So we compare this column, let me change colors, this column and this column. Are they the same? No, they are not the same. So these statements are not equivalent. Are not. because they don't have the same truth table. They don't have the same results. Okay, these statements are not equivalent. And you have to show me. You have to show me both of the truth tables. And the end result, if they're the same, then they are equivalent. If they're not the same, well, they're not equivalent. Okay. All right. So I hope that you guys are all paying attention. You guys are still with me. Let's go ahead and talk about the next question. The next question are about converse, inverse, and contrapositive. Well, when a conditional statement, these are some notes. For a conditional, you have P implies Q. You have the converse, where it's Q implies P. You have the inverse, where it's not the, what you're doing is you're negating, not P implies not Q. And then contrapositive is P switch and negate. So it's not Q implies not Q. Okay, so you switch and negate. So for this particular example, my P is not Q and my Q is not S. So my converse, all I have to do is switch. So you're doing not S implies not R. My inverse, you're negating each one, negating the original. So you're negating R implies negating S. So this would be R implies S. That would be my inverse. And my contrapositive, you negate, you switch and you negate. So first you switch, and then you negate it. So my contrapositive is S implies R. Okay, so you have your converse, your inverse, and your contrapositive. Okay. So basically, you're using what you're given and you're selecting, okay, the P is my not R, Q is not S. And then all you do is follow those little notes that I have. Conditionals, P implies Q, converse, you can switch it. So it's not S implies not R. The inverse, you keep it, but you negate each one. So you negate not R and you negate not S. And the last one, you flip and you negate. Okay. All right. Refer to the table below of the 36 possible outcomes. Determine the number of outcomes between, the sum is between 2 and 11. So if it's between 2 and 11, we're looking for the number 2 less than or equal to S, less than or equal to 11. So let's look at the sum. So which one gives us 2? So one here, this one gives us 2. One gives us 11. Well, less than or equal to 11 would be, this is less than this one and this one. This gives us 11. And this one, of course, 12. So here in between, we have 36 outcomes minus 1, 2, 3, 4. The number of outcomes in between 2 and 11. We get 32 outcomes because the sum is between 2 and 11. Okay. including, well, this one gives us 11, this one gives us 11, these three, if we take these out, so this is 10, this is 10, this is 10, and this is 2. That's the only one that gives us 2. So 32 outcomes. You can also do P minus, so P of the event is 1 minus, sorry, P of the sample, probability of the sample is 1 minus the probability of the event. So the probability of the event is the sample is 36. So 36 minus 4, that's the probability of the event is 32. Okay. So that's exactly what we're doing. All right, find the combination and permutations given n and r. So the number for a permutation, it's something like n factorial over n minus r factorial. We have 15 factorial over 15 minus 8 factorial. We have 15 factorial over 7 factorial. We would have 15 times 14 times dot 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 8 times 7 factorial all over 7 factorial. So here you are allowed to use a calculator, of course. With the 7 factorials cancel. I do want to see your work. So then you want to do 15 times 14 times 18 times 12 times 11 times 10 times 9 times 8. So go ahead and punch this on your calculator. I'm going to go ahead and do that on my end. So I have 15 so I'm left with a huge number, 259,459. I'm not typing anything. 259,459. So that's for permutation. The combination, you have n factorial over r factorial n minus r factorial. You have 15 factorial over 8 factorial, 15 minus 8 factorial. So you have 15 factorial over 8 factorial, 7 factorial. So we know that 15 over 7 factorial is 259,459,200. Divide that number by 8 factorial. And then go ahead and use your calculator. So you have 15 factorial over, and you're left with 6,435, 6,435. That's the combination. This is the permutation. Okay. And you're going to be able to use your calculators here. Now, for number 13, distinguishable arrangements, you have to count the number of letters up to 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial, this is the total number of letters. And then here you divide it by the repeated letters. So how many O's do I have? We have 2 O's, that's 2 factorial. 2 O's. You have 1, 2, 5, 1, 2. So that's another 2 factorial. You have 2L, 1, 2. And we get it. 1, 2. There's 1C, 1T, 1N. Yep, that's it. So then you simplify. 9 factorial, 2 factorial times 2 factorial times 2 factorial. Well, what's 2 factorial? That's 2 times 1, 2 times 1, 2 times 1. So this is 9 factorial over 8 because 2 times 2 times 2, that's 8. So when you do it in your calculator, 9 factorial divided by 8. 9 factorial divided by 8 because that's 2 thirds. And you should get a total number of 45,360 arrangements, distinguishable arrangements. Is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 9. All right, the next one we have is what are the odds in favor of drawing in? Here we have an even number. Now, how many even numbers do we have? We have 1, 2. So 2 versus 3. So we have 2 evens versus 3 odds. So what are the odds in favor? If there would be how many odds against, then you would count backwards. But what are the odds in favor? Well, how many even numbers you have? You have 2 evens, you have the 2 and the 4 versus 3 odd numbers. So 2, so our solution would be D. Okay. All right, let's look at this one. If we dealt with 2 cards successively with the replacement, so whenever you say with replacement, the sample space does not change. Does not. And standing up cards find the probability of getting a heart on the first hand and a diamond on the second. Well, how many hearts? So hearts, there's 13 hearts and there's 13 diamonds. So we have 13 out of 52 times 13 out of 52. So the probability of A and B is the probability of A times the probability of B. So then you multiply the probabilities. So you need to be careful. 13 out of 52 times 13 out of 52. You want to go ahead and simplify. This is 1/4 times 1/4. This gives you 1 over 16. You want to simplify. That's the key. Simplify first before you multiply, or else you're going to get a nasty number, okay? You're going to get it wrong. Please, please, please make sure to simplify. So the probability of getting a diamond is 13 diamonds out of 52. You put it back, so you do it with replacement. So you're replacing the card, and then you have another 13 out of 52 to have a diamond, okay, which is with replacement. All right, next step, we have Bernoulli's trials. So for the Bernoulli trial, it's different. So you use the formula. So this one's mcx, and then you have q to the x, q to the n minus x. Remember that q is 1 minus. So here you have n factorial over x factorial n minus x factorial. And then you have p, which is 0.6 raised to the x. And then we have q, which is 1 minus 0.6, which is 0.4. And then you have 15 minus 12. So then you have 15 factorial over 12 factorial, 15 minus 12 factorial, and I want to see this work. 0.6 to the 12, 0.4 to the third. Now you're going to use your calculator from here. So you have 15 factorial over 12 factorial, 3 factorial. So let's go ahead and calculate that in your calculator. Factorial divided by 3 factorial times 12 factorial. So I'm going to use a calculator that gives me 455. Oops. This one's 455. Just this piece is 455. Now we multiply that by 0.6 to the 12 times 0.4 to the third. This is, I'm using a calculator now, okay? So please go ahead, that's fine, but I do want to see this typed out. Written. This is the last part with the calculator, that's fine, okay? 455 times 0.6 raised to the 12th power. 0.4 raised to the, and that gives me a total of 0.063387. Now I did say round to the nearest 4 decimals. So I got 1, 2, 3, 4. The next number is an 8, so it's 0.0634 because the 8 doesn't go up. So up to the 4th decimal. So this should be my final answer. Okay, so please make sure that you know how to round. Okay? Very important. All right, number 17. On a math test, 24 scores and students are shown below. I'm asking you to construct a STEM table, a STEM leaf table, a frequency table, and a relative frequency distribution. Use 4 classes. All right, so first, the STEM is pretty simple. So I start with 60s or 6. I have 1, 2, 1, 2, 3. How many 6s do I see? 60s. I think I see 3 of them. So I see 4, 4, 4. 64, 64, 64. Now 7. How many 70s do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I see 12 of them, so I should have 0. 1, 2, 3, 4, 4, 71s. 1, so 1, 2, 2 72s, 3 72s actually. So 1, 2, and 3. And then I have how many 73s? I have 173, 2 74s. And that's about it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing one. How many 74s do I have? So I have 1, oops, look at that. 170, So 70, and then I have 1, 2, 3, 4 72s. Sorry, 4 71s. So 1, 2, 3, 4. And then how many 72s? I have 1 and 2, 272. Oh, 3, 372. So 1, 2, 3. How many 73s? I have 1, 2. Oh, I have 2 73s. The 2 73s, these two, and then 1, 2, 2 74s. Then there's a 4, and then there's a 4. For 8, how many 80s do you have? 8. I have 1, 2, 3, 4, 5, 6, 7. So I should have helped in order. So I have 181, and then do I have any 82s now? 83 now, 84, yes. I have 1, 2, 3, 84, 84. Then I have so 1, 2, 3, and then I have 1, 2, 3, 85. And then last, but not least, is the 90. I have 95 and 93, and that's it. And then we have 3 and 5. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I should have 24. Okay, great. So this is the stem, just the stem. Now let's go to the frequency and relative frequency distribution using 4 classes. So here is my x, there's my frequency, there's my relative frequency. Okay, so starting at 60, 60 to 69, 70 to 79, 80 to 89, 90 to 99. So between 60 and 69, how many do I have? Well, I have 1, 2, 3. 3. This is 3 out of 24 in total. You have to simplify. This is 1/8. So 1/8 as a decimal, or sorry, as a fraction, as a percentage, 12.5%. Now between 70 and 79, there's 1, 2, 3, there's 12 of them. So 12 out of 24, this is 1/2 or 50%. You have to show me your work. Between 80 and 89, we're looking at 1, 2, 3, 4, 5, 6, 7. 7 of them. 1, 2, 3, 4, 5, 6, 7, yep. So it's 7 out of 24. That one does not simplify, but we do want to have the percentage. That looking like 29.1%. You do a ballpark, 90 to 99. You have 2 of them, 2 repetitions, 93 and 95. That's 2 out of 24 or 1/12, which is equivalent to 8.3%, roughly. So then I want to see both of these together. I want to see the stem, and then I want to see the frequency and relative distribution, starting from 60, and I have 4 of them. So notice I have 4 classes. The first class, the second class, the third, and the fourth. 4 classes, and I'm beginning with 60. Okay. Let's go to the next one, number 15. Find these classical fractions of numbers or data lying within 3/2 standard deviations of the mean. Use Chebyshev's theorem to solve the problem. So Chebyshev's It's 1 minus 1 over k squared, where k is 3 halves. So you do 1 minus 1 over 3 over 2 squared. So you focus on the fraction, 1 minus 1 over, well, 3 halves squared is 3 halves times 3 halves. That's 9 halves. So 9 fourths, and that's question across. Now this one is called a complex fraction. So this one's 1 minus 4 over 9 around. So whenever you have a 1 down there, so it's 1 divided by 9 over 4. You don't know how to divide fractions, so it's 1 over 1 times 4 over 9. That's how you get the 4 over 9. Okay? You convert it. Now 1 minus a fraction, this is 1 over 1 minus 4 over 9. Common denominators, multiply both top and bottom by 9. And this is the steps that I want to see. So 5 over 9, this is your final answer. Five over 9. Using Chevy Stokes theorem. So this is the tricky part, is to know how to convert this complex fraction into this easy fraction. And using common denominators. Pretty simple. Okay. Well, let's done. Number 19. The test scores of 15 students are find this should be the sixth decile. The decile means 60%, because it's 6 times 10, which is 60%. So if you have 15 students, you multiply 15 times 0.6. The 0.6 comes from the convert the 60% into decimal. So using your calculator, you're going to go, okay, so what's 15 times 0.6? That's 9. So then you're going to go to your data. You're going to cross 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's the next number after that. So your answer should be 74. This is your solution. So you use your decile to tell you how many items to cross out. It's saying cross 9 items, and then it's the following number. Okay. Now find the mean, the median, the range, and round the standard deviation to the hundredth place. So here, to find the mean, well, let's do, you add 70. Well, first I'm going to write this in order. So this number is 21, right? 21, and then there's 51, and then there's 53, there's 53, and then there's 70, and then there's 72, and then there's 81, there's 82. Oh, I'm missing one. See how you have to go slow. There's a 74, there's a 72, there's a 70, and then there's an 81 and an 82. Yep. So then you want to find the mean. So I'm go ahead and add them together. So you're going to do 21 plus 51 plus 53 plus 53 plus 70 plus 72 plus 74 plus 81 plus 82. All divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 21 plus 51 plus 53 plus 53. Use the calculator. 51 plus 53 plus 53 plus 70 plus 72 plus 74 plus 81 plus 82. It looks like 557 divided by 9. Let's see if it goes in evenly. And it doesn't. So this is roughly 61.88. 61.89. Okay, I'm going to accept this. Now the median, well, you just cross one, 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 one. 70 is the median. The range is the largest value minus the smallest. So the largest is 82 minus 21. We get 61. So 61 is the range. Now the last part is the one that can take a longer time. We have to do the standard deviation. So for that one, I'm going to start by rounding. Standard deviation. It's the mean minus the value. So your mean was 6189. That was the mean. So then you do 21 minus 60. I'm going to round this to 62. I'm going to round the mean. This is just for the standard deviation. So squared plus, then we're going to do 51 minus 62 squared plus 53 minus 62 squared plus 53 minus 62 squared. I have around the mean to 62. Your mean probably will be a whole number, okay? So don't worry. You will not have to round for your mean. Plus, we have 70 minus 62 squared plus 72 minus 62 squared plus 74 minus 62 squared plus 81 minus 62 squared plus 82 minus 62 squared. So I'm going to go ahead and add, subtract, and square. Okay, so you sum and square the quantities. So let's go ahead and do that. I'm going to use this a site that I call Wolfram Alpha. So I'm going to show you how to do that. But I do want to see a work. So I'm going to start this show and I'm going to use this site. And I'm saying that this Wolfram Alpha is minus 62 and then plus. So all I'm going to do is I'm going to take these and I'm just going to copy some of them. So the first one was a 21, the next one was a 51, the next one was a 53. The next one was a calculation, so 253s and have 70, and then you have, oops, 70, and then you have 72. And then 74, and then 81 and 82. And then 82. And after that, after calculating that, I get 3,033. So you're going to take that number, you're going to take the square root of 3033 all over n minus 1. So remember, n is the total number of data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have the square root of 33 divided by 9 minus 1. We have the square root of 33 divided by 8. So we're going to calculate the square root of 33 divided by 8. And I should get, as a decimal, the square root, get 19.4711. You round to the nearest hundred, so this looks like 19.47. So stop the share. So we ended up with 33 when we subtracted, and then we took the sum, and then you do the square root of 33 divided by n minus 1. N minus 1 is 8. So it's the square root of 33 divided by 8. The standard deviation is 19.47 because I said round to the nearest hundred place. So the tenths and the hundredths, we have 19.47. I do recommend you to watch this video very carefully, maybe once, maybe twice. Thank you, and I will see you until next time.